Okay, all systems go. Okay, so welcome to Gideon Redelinghuys, and let's talk about Python at CloudFlare.
Okay, like any good, like any good speaker, I'm going to start with the apologies first. So first of all, I might swear, but I'm going to try not to, really hard. The other is this horrible American accent I have. So I'm actually from the Strand. If you don't know where that is, congrats, don't find out. But terms like Ossia, Massacre, that's familiar to me. So I have this horrible American accent because I spent 1 year in San Francisco and I got back this morning. So I'm still picking up my South African accent back again. So first introductions. So for Americans, they normally pronounce this as Gideon Ridiculous. They just can't do that last part. Fortunately, I'm not my brother, who's Wouter Redelinghuys. They just do Wouter Ridiculous. So yeah, I'm Gideon Redelinghuys. I can actually say that here, and people understand it. Yeah. The other part is CloudFlare. So, first of all, if you're wondering about my background, I studied at Stellenbosch University. For my honors, I did a paper on P versus NP. For my master's, I did a thesis on formal methods and symbolic execution for the NASA Java Pathfinder project. Then I moved to a small company in Stellenbosch that did telecommunication software for small telecommunication stuff. Then I moved to EC2, Cape Town. And then now I'm at this company, CloudFlare, in San Francisco. So, CloudFlare. Who is CloudFlare? Let's find out. So, CloudFlare is, roughly speaking, a CDN. So what is a CDN? It's short for Content Delivery Network. Effectively, it's a proxy. If you have a website in America and you want people in Russia to have a good time, like they want a good response time of that, we can proxy it to Russia for you. So people in Russia see faster than light experience. So we can break physics for you until fake it till you make it. Once the physicists have broken the speed of light, you don't need a CDN anymore. We'll be out of business. The other part, we also provide is security. So if you want SSL but you don't want to think about it, we can do it for you. So if you have a website and you don't have SSL yet set up, you might be in trouble because Chrome and Firefox will stop that soon. But for free, you can put yourself on CloudFlare. Boom, you have SSL, and you will always stay up to date with whatever Chrome and Firefox supports. And then our biggest seller is DDoS protection. So we see the biggest attacks in the internet. We are constantly being mentioned in headlines, like Forbes and all that stuff, and we have to deal with those attacks. For instance, this one. The other one after this, so there was a Baidu customer from China called Baidu who simulated a 1 terabit attack against us, and we handled it. And that's the biggest attack ever in history. So also, where are we? We are there, across the world. So I'll call them for this talk POPs. So it's point of presence or data centers, DCs. There's many words you can use for them, but that's basically this is where we can see traffic. So for instance, if you go to reddit.com here in Johannesburg, you will hit this POP. If you are in China, we've got you covered well. And we also grow these things at roughly 1 a week. We add 1 a week. I think we added 1 while I was in the air, so this map isn't up to date. Things that are new on this map is we didn't have a Middle Eastern presence last month. We now have 4 POPs. This was empty about a month ago. That's full. So we're growing really fast, and we have to keep up with the times. So also, if you're wondering who's using this, some of our customers are Reddit, DigitalOcean, FBI, Donald Trump, and Jeb Bush. So if you keep up to date with your American politics and you visit their websites, you'll be going through us. So what problems do we face with this network of ours? Well, we need to provide the best product and not break the internet. So the problem now in our internet world is it's now a really, really mesh of clouds. If one of the clouds go down, there's a bad experience for everyone. For instance, Dyn DNS went out, the biggest DNS provider in the world, and it looked like CloudFlare went down as well. We didn't. It's just that basically no DNS name resolved. There's, of course, many stories of Azure going down, AWS going down just last week, affecting a lot of the internet. We see about 5 to 10% of the internet going through us. So if we break 5 to 10% of the internet. We have a hashtag that we use when we sometimes tweet, save the web. You might see it float around on Twitter. So how do you get best product, right? So we have to stay ahead of the competition. So there is a lot of competition in the space. It's the biggest one is called Akamai. Some of you might have heard of them. But yeah, we need to stay ahead of them. So the first problem we have is no product stays the best on its own. You have to constantly keep evolving. Otherwise, you'll fall behind. So one of the ways of evolving is you need to create something, test it, and deploy it. For creating things, there is many business words I can use, synergy, agile, all that kind of stuff. I won't. But mainly my talk will focus on the tested and deployed part. Because I personally feel that if you give great tooling when it comes to testing and deploying, the creation part becomes easier. Yeah, and then there's a nice Dilbert comment for you guys. So the tools I'm going to talk about is two tools called Salt and CFSetup. Both of them are written in Python, not these two. I apologize for the confusion. So yeah, does anyone here use Salt? Okay, so I can't just BS my way through this one. So first of all, Salt. What is Salt? And I just lost network. The Wi-Fi just went down. No. I have to save this as a PDF for these scenarios. Basically, Salt is a configuration manager. What is a configuration manager? To summarize, it is something that you use to decide how a machine should look like when it boots up. So with Salt, you will say that, oh, when this machine boots up, I want to see this software on it at these versions, please. We're running this software. The way we express our configuration, we use YAML and Jinja templates. Also, we have to obviously encrypt a lot of our data, and we use GPG for that. The other cool feature of Salt is remote command execution. So if you have many machines, and you want to find out, you want to tail a log maybe, you want to grep a log, or you just want to find out how your Asian machines are doing, they have a great query language for that, and you can run any command you want, or state. And Salt claims to scale up to thousands of Salt minions. And normally in a kind of default setup, your setup will look like this. So you have one central Salt master and many Salt minions, normally one per physical machine, and they all communicate via 0MQ, which the previous talker covered. So my talk actually covers the problems and how we dealt with them in Salt. So what's actually cool about this conference is we are all Python people. And some of these problems aren't properly solved, and it's all in Python, these problems. So there might be some cool Python libraries that either I or the Salt people are not aware that we should be using. We're maybe using something wrong. Actually great to get feedback on figuring out how to use Salt better. So first of all, Salt by default stores. So okay, first of all, what is a job? So when you do remote command execute something on a minion, it is called a job. So you say, cat a file for me, please, on all the machines. So Salt will keep track of the command you sent and the return sent from every minion. And by default, Salt will store that in many files and directories on your Salt master machine. This does not scale. This does not scale at all. Our machines, they just get pegged on a hard drive, just writing out many files. So either you do a file system optimization, or you just move away from doing files to going to Postgres or some other amazing database. They're all amazing, right? So that's one of the things we did. So we wrote a patch for Salt to move away from the file hierarchy system to the more DB side of things. That was pretty cool. I must say Python, the PsychoBG is pretty cool library. I had a good experience with that. Another problem Salt has that we had to solve is for some reason they decided that, so they have the cool concept that one Salt minion can be connected to many Salt masters. But the law says that every Salt master will speak on the same port. I don't know why they just did that as an oversight. And so the problem is in our world, we run stuff in Docker, so we run maybe the same service on the same machine, and maybe that same service can't share the same port. So we had to write extra patches for them so that they can support Salt masters on separate ports, which is really weird because Python encourages you to express stuff as addresses, like many sane languages, where you specify the protocol, TCP, the IP address, and the port number. Because when you give me a service address, that's what I expect, not just an IP. It's fairly useless. So they had this weird concept of that. The other thing we want to implement is the support of SRV records in DNS. So DNS actually has its own built-in concept of service discovery that you can use SRV records for. And I couldn't find a good Python library yet to solve that problem for me. So, and I didn't want to write that myself. The other thing is the other problem we have for Salt masters is, so obviously all of this is encrypted, this communication. So they have encryption keys on the Salt masters, and they have encryption keys on the Salt minions. If you're using the same Salt, if you're using more than one Salt master, the Salt master all must use the same key. That becomes a problem for us. We have to manage our keys. We have to make sure they're secure. It's a mess. So what we want to do implement now in future is the ability to actually have the concept of certificates, and then you have keys that's signed by certificate, and you can authenticate by certificate. Again, if someone in the Python world knows how to do that easily, please do it. Please, thank you. Yeah. Is there any questions? I do better in a dialogue than in a monologue. But yeah, if you have any questions, please shout out. So the other problem we have with Salt is developing Salt. So Salt has the concept of states and pillars that you use to specify how your machines look during boot time. That's hard to write, especially when you have legacy machines. So you have a machine running for 5 years, uptime 5 years, and you're like, okay, we want to reboot this sucker. And you're like, okay. So the first thing we do is we take Salt, right? And then we try and figure out, so Salt, how do we represent this machine in Salt? And you take your best shot and your best guess. And then you try and boot, obviously, other machines up beforehand and see if it spins up the same way, and then you may be there. But in the end, there's still a risk. So some of the ways we're trying to address that is we have the concept of staging Salt masters. So you still have a production Salt master with all your Salt minions connected. But then we also have the secondary Salt masters that are running code that we're not sure yet should be in production, and we have our minions just talk to them selectively. We also have a CI, it's the build server. The build server that runs our high states. So high state is just simply take an empty machine and put it into the state that we specified. So we have our build server do that constantly, and to ensure that our Salt stuff still makes sense. A feature we added in-house to Salt and is now available in the latest Salt, but it has nothing to do with our feature, is Git branches. So you can specify your states and your pillars in Git, but then you can also fork off branches, and you can ask Salt to please use the branches of your states and pillars, and that makes it very easy to develop states and pillars. And then obviously, we can also use Docker containers, and I will elaborate on that further later in this talk. So one of the problems we have as well, another problem, so many problems. Why can't we just have that silver bullet we were promised, is the network. So the one thing you have to notice is our Salt master, we have one single Salt master, and then we have a Salt minion on every physical machine across the world. So the Salt master talks over the normal common man internet to these Salt minions. The internet doesn't work. It breaks a lot. we've seen countries just go dark, or worse, they just drop some packets. Salt by default uses 0MQ. Unfortunately, 0MQ seems to deal badly with these really, really edge cases of weird packet loss, especially weird delays, weird rerouting and duplication of packets. So we're still trying to solve that problem. We contacted Salt about this. Their suggestion is this thing called Salt Syndic, which is basically just a Salt master proxy. So we put one Salt Syndic in every physical location, and then we keep this communication within the POP where we have a reliable network, and we just minimize that amount of communication we have over the internet. Salt is also looking at new experimental network stacks called RAET and Tornado. Both of them on experimental, has the experimental tag attached to it. If anyone here knows of a better network stack or knows how to take them out of experimental and into production, please, I beg you again. Yeah, I just don't know what's wrong with normal TCP, but anyway. And then the next problem we have with Salt is the command line tool. This is an interesting case of where they made a tool that's very good for, that's roughly good for humans. Humans want to just run one thing, and they want somewhat readable human English coming back. So it makes a decision for you. It has built-in timeouts within itself that you have no control over, just so that it can seem responsive to a human being. That's very bad when you try and automate on top of it. Salt can give you JSON output, but it loves to put a standard error output in between, or even errors in standard output in between. It times out. The JSON is unparsable. Yeah, it's not the greatest. So we've actually rewritten all of this into something, an internal API we have on our side, and we have a tool called Deployer for now, which does all our deployments using this internal Salt API. And then something we're playing with now that I'm super excited about is something called SaltBot and HipChat. So for those unfamiliar, HipChat is a chatting service for your company. It's like IRC, made by Atlassian, the guys from Bitbucket. So HipChat, you'll have a channel where you can speak to SaltBot, and SaltBot will speak to Salt for you. So in a common channel for everyone, you can see what people are doing with Salt and what they're getting back. And so you can audit yourselves if you're using Salt in the appropriate manner. So the future of Salt that we're trying to push for within the Salt community is see if we can improve the command line tool. That's a huge problem for us. There is the key management problem. So for some reason, they don't do certificates. And then we need to figure out how to make it work across the internet in all corners of the globe, because we have our POPs everywhere, including Johannesburg. And unfortunately, the internet sometimes goes down in Johannesburg as well, and I get sad. It's like, come on, guys. Come on, represent South Africa. So the second tool, CFSetup. So this is an in-house tool. It's not open source. Unfortunately, I cannot show it to you, but I can talk about it. And hopefully maybe someone will get inspiration from it and write an open source clone of it. I'd like to see it happen. So what is CFSetup? So I think everyone's probably used Docker, right? Or like played with it or did the tutorial, right? How many? A few people. Yeah, so Docker is a word that people use to solve everything. It's like, you have a problem, have you Dockered it yet? It's a new turn it off, turn it on problem. Is it in Docker yet? So we started using Docker to try and understand how we can create test environments and all that stuff. We figured there's some common patterns we use with Docker, and we can maybe start wrapping it up in a common tool that everyone can use. And this is what CFSetup became. So the cool feature of CFSetup is we try and make it as easy as possible for a developer to spin up a Docker container that looks just like production, as close as we can get. And then he can run his tests in there, he can run his code in there, and he can see if it behaves well. So an interesting question is, why did we write this in Python? So the first thing was, looking at CFSetup, is we weren't actually even sure what we're making. Like, it's a hassle running these Docker commands. Let's just make something that does it for us. Hey, maybe some other people might want to see this. So with Python, we were able to develop this really fast. And one of the interesting things of using an interpreted language is some developer on his computer will have a problem. You're not quite sure what it is, and you can just both jump on at his computer and just start adding to the code, removing to the code, and just trying to understand what is the problem he's specifically seeing. That works great within our company, just trying to develop this tool and figuring out what it's supposed to be. So how does this work? Effectively, it uses a makefile. Yeah, we're back in the 70s now. We have a makefile where, so you have a project written in some language, and you have a makefile that has specific targets that says, this is how you should build something, this is how you test something, this is how you package something. As long as you follow those conventions, CFSetup can do those things for you. So now you can say, hey, CFSetup, please build my project within this environment. So the great thing is you don't have to manage dependencies anymore. If you're building on Debian Squeeze, which is almost 6 years old and runs on really old libraries, and you have to link against them, you can do that without managing your own machine. Or you want to do Fedora 23 now, CFSetup can spawn up a Fedora 23 box and build against Fedora 23 libraries. It is super powerful, I must say, because we run various different distros at different maturity levels, and the ability to just churn out packages that's built for all these kind of environments is great. So some of these kind of tools that you can use, there's something called CFSetup spawn. So if CFSetup spawn, you can specify a salt minion type, and then salt will actually high state that Docker container into that state. So this is where salt and Docker really complement each other really well. So you can say, Docker, we have this type called the load balancer machine. Docker will spin up it with all the appropriate salt configuration as a load balancer. The salt master will contact it and high state it as a load balancer. There's also something called CFSetup enter. So this weird problem with Docker is it's actually quite hard to enter and exit a container. It's the first problem you face when you do Docker. It's like, okay, it's up. How do I exit this without killing it? What do I do? So what's interesting is that's like one of the most useful things. And then CFSetup build. So when you're within your project and you have your makefile there, you just run CFSetup build, what flavor of the distro you want, enter. And you have Debian packages come out the other end, built exactly for that environment. And then there's also CFSetup test, so run the test actually against that distro environment. So Debian Squeeze might be running an older Python than Debian JC, and you want to make sure that you're compatible with both Python versions. In my past, I've had to deal with a lot of Ruby incompatibilities, and so this also helps making sure that you're as compatible as possible across all environments in your production. So some freebies that this tool gives us, it spins up an apt and local DNS container as well. So you actually have your own repo in your environment, and you can register your own Debian packages. You can modify the Debian package manager as you would like to see how your stuff will react, and then also you can modify the DNS as you want and take complete control of your environment. These freebies are actually called appliances, and so CFSetup has all these concepts of appliances. The other cool thing as well is when you do a spawn, it doesn't have to be a salt type. It can also be a Docker file now. So you can either specify your container as a salt type or as a Docker file. So what is some of the major benefits of this? So we have some interesting projects that have some really cool requirements or just insane requirements. ZeroMQ is one of them. Trying to build ZeroMQ, I salute you. It's really hard, and it's very different based on the distro you're building it. And even Debian struggles to package it. If you want to install ZeroMQ4, you might have to install ZeroMQ3 to get that, depending on the distro. If you want ZeroMQ4, you have to install ZeroMQ5 maybe. There's no ZeroMQ4 package, I think. And so it becomes super confusing. And so people struggle to package it. And that's all to do with linking of libraries and super hard. So when you put your stuff in a Docker container, you have better guarantees of isolation, not full isolation, but better guarantees. Do not confuse this with security. This is not a security layer. It's just not trying to corrupt your own file system. We've seen weird projects where they actually try and modify their own code, and it corrupts their own code. Yeah, there's some evil projects out there in the world. Another useful feature of this tool is something called stacks. So obviously you might just want to spin up one container. Your environment actually consists of a set of containers. For instance, a load balancer, an Nginx container, and a Postgres container. You can specify that as a stack, and CFSetup will spawn that all together and try and manage it for you. So, a quick side note about Python and Docker. So when this project started, Docker Py was before version 1.0. And the experience of the developers at that time was it's completely broken. They found it really, really hard to work with. The other thing as well is this is just a wrapper above the human that was doing the Docker commands. So we actually just fork out to Docker. And you can actually see the exact Docker commands we're using. And you can reproduce it yourself if you want to debug what CFSetup is doing. That's super useful. I don't know, I'll get touched on the next slide. Well, yeah, next slide. Is Docker regresses in a really weird ways between versions. Especially if you start running Docker in production, good luck. We do. If you upgrade from 1.7 to 1.8, you will see differences in behavior. You will see the startups different. You'll see it starts up differently. For instance, if you're on a distro now that uses Firewall D, no, you basically have to stop Firewall D. It doesn't work. It doesn't support it anymore. If someone is running AC Linux, good luck. That actually started working recently, but I think it broke AppArmor or something. It's Docker versions are hard to manage, and that's still one thing that we're trying to deal with using CFSetup and see if we can deal with those problems. So the future of this tool and internally into our company is we're just going to try and add more appliances, try and get it even closer to production. So one of the things we do at CloudFlare is we build our own kernels. Docker doesn't really give us that ability to simulate our own kernels, but we'll try and see what we can get. And then also every developer runs this natively, CFSetup, and every developer's laptop is on a different distro, a different OS, with different libraries. And it's insane the amount of problems you see Docker has. Like someone's running Firewall D. Why? Why are you trying to be secure? Don't. Someone's running AC Linux. No, that doesn't work with Docker anymore. So yeah, it's hard. It's hard to manage Docker. So the conclusion is with Salt and Docker together, we're able to write and test our code much faster than I think we were ever before. We might be able to keep up with the internet, unlike a certain team was unable to keep up with some other team. Because it's very important. It's super important to be able to have confidence in your production environment or your testing environment and in your deploying environment that it's safe. Any questions?
Great. Could I have a volunteer to run the other mic? Cool. So, questions?
So you're talking about automating testing kernel builds or something?
That's something we would like to do.
Yes. So there's this Michael Koshman, Phoronix Test Suite or Studio, PTS.
Okay.
It's made by a guy that runs some Linux like general hardware review site called Phoronix.com, and he seems to do a lot of things where you do custom builds of kernels following Git, doing bisects, tracing, and debugging things, and has a complete set of open source tools that he's using to do all these things. And you can maybe just have a look at that.
Yeah, we'll definitely have a look at that.
All right,
thanks.
That's all.
Thank you. Well, that's what I was trying to also like share with the Python community. Is like we need to fix these problems.
Just a quick question. So I looked at Docker a while ago, but on a small scale, it seemed to be like more effort than it was worth. Obviously, you guys are making it work. So, what level do you see it be like the level at which it actually starts paying for itself? Like,
so the Docker stuff is super useful when you have many teams in your company and they're all trying to do their own thing, and you want to put more trust in their hands. Like, guys, here, just put it in a Docker container. we're fairly confident you won't break anything else as long as it's in a Docker container. So that's one use we got out of it. But if you're in a tightly coupled team and you don't want to debug Docker, which is an overhead that we had to pay, it's not worth it. And also, it's not worth. Some people confuse it with security, and I think if they put something in a Docker container, it's more secure. It's definitely not.
Hey, Gideon.
Oh yes, sorry.
So I'm curious to know why salt.
So why salt? It was chosen before my time. I wish I had a better answer. So there's Chef and Puppet, and we do look at them every now and again and go, that would be nice. But we stick with salt. We've now sent many patches to them. We're kind of invested into that now. We've contacted them now to find out how we can get salt into a better place. But yeah, when I was rewriting the salt command line tool, the obvious question was why? Why am I doing this?
Because the interesting thing is a lot of the problems you're talking about there have been solved by Chef and Puppet a long time ago.
Yeah, so Salt claims they've solved problems that Chef and Puppet has. So every time you rewrite code, you just introduce new problems.
So with this salt,
Sure, yes.
you pushing all of these updates across the line to
Yeah.
all of these servers all simultaneously. Is that right?
You can.
Yeah.
So that's what the deployer tool now introduces. It does it in a batch mode, so it has a rolling window where it
Yeah.
deploys and tests as it deploys.
So how do you stop from inadvertently destroying all those machines at
So
once?
someone can run sudo shutdown now on all machines. Yes. The problem is I've had many times this problem, like, what happens if we have a rogue engineer and he wants to do something bad? It's gonna happen. You can't stop. You can only stop so much. You can only stop so much rogueness or stupidity. Yes. Yes. So yeah, unfortunately, it seems like I've seen other big companies where they just delete a single line of a DB and it all goes down. We believe we hire the best engineers we can, and we give them the training we can, and they should understand what they're doing. Yes, if the company is still standing, right? Yeah, but we do take it very serious, the commands we run. We don't just willy-nilly run whatever we want. We normally have at least one engineer just look over the shoulder and just confirm whether it's even necessary to run that command. Yeah. What if he sneezes? No, he doesn't sneeze.
Yeah, so obviously you've got salt to put things into a known state, but how do you get from having a machine that you take out the box to having an operating system installed with a salt minion?
So there's one step that Salt doesn't give us. So if you have a completely blank machine, Salt can't put an image onto it, can't put an OS for you. So for that, we use something called Perseus, which is just netboot. We just netboot those machines into a blank OS.
So what did you say the tool was called?
Perseus. I would suggest you look at other tools as well. It's a legacy tool we still have hanging around. Yeah, there might be better options.
Just a quick one on your salt state development. You mentioned. Hey, sorry.
Oh, there you go. Yes.
You mentioned that you have a staging master that you sometimes point some of your minions at,
Yeah.
and you've also talked about the really cool Docker infrastructure that you got. Do you guys, is it a separate sort of stack that devs or salt state devs use, or can they do everything through this little Docker CFSetup tool?
Okay, so you can spin up with CFSetup. You can spin up your own little salt environment with salt master, salt minions. That's completely separate from production. But then when you want to move something into production and you want to confirm whether it is a good thing, you can then put it onto our big salt staging masters that does touch production. And because they're a staging salt master, we can roll back very easily if something goes wrong.
And have you ever had issues with multiple devs working on similar states, breaking dependent states on that thing? Does it?
Well, so we have had problems where, if salt, it's easy to make bad states. And then normally we have processes in place. Salt has dry runs, so we always run dry runs, and we see what Salt's opinion of what's going to happen. Salt sometimes gets it wrong. I've once high-stated something, one of our website boxes, and Salt just decided, I'm just going to wipe all the configuration files. And that's something that's another thing we want to bring up with Salt is maybe not to do that. Fortunately, in a modern infrastructure, you have something like load balancers. You just take the box out and then you try and fix it. But yeah, there's still some sort of stuff we have to solve. Also, if you make bad state, if you write something bad in Salt just gives you a random stack trace effectively. It's really hard to debug what it's doing. For a price, they will help you a lot. But yeah.
Hi. So why CFSetup and not Vagrant?
So we actually do use Vagrant a little bit, but as far as I know, Vagrant can't give us like the build part. Like you can't ask Vagrant to just quickly build this project for me, as far as I know. Where CFSetup can do, you can just say CFSetup build, and it looks at the make file and it builds the project for you. And also, it has this concept of spinning up an app repo for you and the local DNS repo, stuff we couldn't get in Vagrant at the time. But Vagrant recently released something called Auto, and that seems more CFSetup-like, which we're quite interested in.
Just a question from me.
Yeah, sure.
What's holding you back from open sourcing CFSetup?
It's just this tool was like, it's just a mesh of everything we've done internally. I don't think we'll be that embarrassed. We've seen some bad code as well. No, it's not the goal at the moment of the team. They have too many milestones internally to get the tool to work for more production use cases. Plus the name CFSetup, it's not very global. It's CloudFlare setup. So we have to rename it as well, and that's always hard, right? Getting a good open source name. Yeah.
Anyone else? Okay, well, thanks a lot, Gideon. That
Cool.
was fantastic.